All right, so we've taken a look at an equation in slope-intercept form, and we've constructed the graph. Now we are going to work in the other direction, and we're going to get a graph and ask ourselves, well, what's the equation in slope-intercept form? So the equation of a linear function can be created using the same knowledge. If a linear function is expressed in a graph, we can identify the slope and the y-intercept, and simply plug those values into y is equal to mx plus b, where m is the slope, b is the y-intercept. So I'm going to take a look at my graph and identify my y-intercept and my slope. Looking at graph A, my slope, well, I need to find points where I cross a grid. To put it more mathematically, I need to find points where both coordinates are integer values. And what we see here as we move left to right is I go up vertically 1 unit, go horizontally 1 unit. So my slope here is my vertical change is +1, my horizontal change is +1. So my slope here is going to be 1. My y-intercept is -1. So the equation of my line is y is equal to 1x minus 1. Y is equal to mx plus b. And maybe we don't like that too much. Maybe y is equal to, I'm going to write a little bit of work here. I jumped the gun there. Y is equal to mx plus b. And what we get is, if we plug in the values for m, y is equal to 1x plus -1. Now, in this first term, the convention is in math, when we have a coefficient of a variable equal to 1, we just write x. We don't write 1x. And what I've underlined in green, what I'm saying is, if I add -1, that is simply the same as subtracting 1. So that is the form that I can write. So my equation is y is equal to x minus 1. All right, let's look at B. Blow it up. Now, I cross the grid right there and right there. I don't need to cross at those 2 points, just as long as they're integer values. The slope will work out to be the same. And what I notice is that as I work left to right, that I go down 1 unit. To get to my other point, I go over to the 1 unit. So my slope, my m, my vertical change, my change in my y over my change of x, so the vertical change over the horizontal change, my y value changed by -1, my x value changed by 1. So my slope here is actually -1. And it should be negative because we are going downhill. Maybe you don't like that. Maybe you said that's not the way I saw it. Sure. Now I'm going to take this point and I'm going to travel all the way to that point. What I notice is my slope is still my change of y over my change of x. Now, how much did my y change? I noticed that my y went down 4 units. How much did the x change? The x changed by 4 units. So the change in y is -4 because I went down 4 units. My change in my x coordinate is +4 because I went to the right. So -4 divided by 4 is -1. So my slope still is -1, same thing. I take a look at my y-intercept. My y-intercept is 3. So my slope-intercept form is y is equal to mx plus b. And if I can plug in my slope, so y is equal to -1x, right? Slope is m. My b is 3. Now, we don't write in algebra when it's -1x, when the coefficient is 1, We don't include it. So I would just simply write y is equal to negative x plus 3. All right. Having good times, are we? Whew, this one looks a little bit nasty. Slope. So remember when I said you have to find points where your line crosses the grid so that your x and y coordinates are both integer values. Right there. There it crosses the grid. Now, as I go up this line, it doesn't look like it crosses... Pardon me. That was really nice. As I go up this line, it doesn't look like I cross at a grid mark or my x, y values are non-integer values, except for at this point here. And it doesn't really matter maybe what these points are. What I can do, though, is my slope. I can identify it. My slope is my change of y over my change of x. And what happened is I like to draw a picture. I went up, it looks like 5 units. 1, 2, 3, 4, 5. Yeah, I went up 5 units. And then I went to the right 1 unit. So my slope is going to be delta y over delta x is 5 over 1. My slope is 5 over 1, but probably better known as 5. My y-intercept, now I ask myself, where does this cross the y-axis? It crosses it also at 5. So if m is equal to 5, b is equal to 5, the equation y is equal to m, 5x plus 5. Y is equal to m, x plus b. Fair enough. I like to pick low-hanging fruit, right? Whenever you approach a question, if there's a give me to any of this, I try to get it. So the easiest part about this probably is identifying the y-intercept. What I'm able to see is my y-intercept is 5. What is my slope? I don't know. It's a little bit harder of a think. So I pick a point, and what's really nice about my y-intercept, it happens at integer values. And as I go down, I'm trying to see where I cross at an intersection point of the grid, where my x, y coordinates are integers. And there it is. There's my next crossing of the grid. Now, just to recall, if you want to get all fancy on me, for sure you can, and say slope is really ya minus yb divided by xa minus xb. And you can go crazy like that. You can identify your coordinates for the x and you can identify your coordinates for the y. Great. That'd be awesome. But perhaps a little bit too tough. Not too tough, just more than we need. So as I go from the green point to the black point, I know my slope is delta y over delta x. That is the vertical change over the horizontal change. My y value from the green to the black, it goes down 5 units and it goes over 2. So down 5, 2 to the right. So my change in my vertical would be negative 5. Change in a horizontal would be 2. So the slope is negative 5 over 2. And if I have y is equal to mx plus b, and my m value is negative 5 over 2x, right? My m value is negative 5 over 2, plug that in. And my b, or my y-intercept, is 5. There is my equation. I feel like it's much the same here. The hardest thing when you encounter these graphs is to pick out the points where your values or your graph run across the integer values of your grid. So instead of writing all of this in, I just want to maybe point out the skill where we cross the grid. So for E, I believe, now when I say I believe, my eyes are the limiting factor, but I believe I have 3 points on that line that have XY coordinates that are integers. And I think I've denoted them there. And for F, I think here, I think there, and I think there. So I can build my argument based on those points. To find the slope, it doesn't matter which combinations of points that you use, you should always get the correct answer. All right, have a good one. If you have any questions,